Hi. So, today we will discuss some tutorial on MapReduce. Already we have discussed on MapReduce. So, today we will try to solve one or two problems, or rather try to see how one or two how we can decompose a problem into a MapReduce problem and how to work on it. So, if you remember that the MapReduce paradigm is used for processing huge volume of data, where parallelization is possible and primarily rather developed by Google and later on used in various fields. So, what we will do, we will initially couple of slides, we will have a quick recap before we take up one or two problems related to this MapReduce framework. Okay. So, as we discussed already, so it is a programming model developed at Google, right. Implement large scale search, primarily the basic objective was to implement large scale search, text processing on massively scalable web data using data stored using Bigtable and GFS distributed file system, Google file system and big data, Bigtable. So, this was objective of Google, which it started with. So, designed for processing and generating large volume of data by massively parallel computation utilizing tens and thousands of processors at a time, right. So, there are huge number of processors to the tune of tens and thousands. So, whether if there is inherent parallelisms inside the things, whether I can exploit it into the thing. So, it is designed to be fault tolerant, that means ensure progress of the computation even if the processor or network fails. So, it should be fault tolerant to the extent that even there is a failure in the processors or the network, it still the working should go on. So, that was the basic assumption or basic say precondition of doing this, or that was basically this what they was taken up, right. So, there are several things like Hadoop, open source implementation of MapReduce, incidentally it was developed by Yahoo, available on pre-packaged AMIs on Amazon EC2 and so on and so forth. So, if we look at apart from its history, so it is a parallel programming abstraction, right, used by many different parallel applications which carry out large scale computation involving thousands of processors. It is again, as we have seen, the underlining fault tolerant implementation both on the data side and on processor and network side, right. So, everything is fault tolerant, divided into two phases. One is a map phase. So, mapping the given a problem, I divide into two phases. So, it is mapped into a intermediate result and reduced to a again the reduce function or reduce phase, reduce those intermediate result to the actual results, right. So, in doing so, what we have seen in our earlier lecture or earlier discussion on MapReduce, that we can have parallel efficiency we can achieve substantial parallel efficiency when we are dealing with a large volume of data and there is inherent parallelism into the process, right. So, what we look at, there are m number of mapper processor and n number of reducer processors which are assigned work based on the problem, right. So, there is a master controller, m mapper processor and say n number of reducer processors which work on that, right. And in some cases this mapper and reducer processor can share the same physical infrastructure, right. So, that means sometimes they acting as a mapper and at a later stage acting as a reducer type of things. So, it is our capability of the developer or it is that how you devise this mapping and map and reduce functions, right. Implementation also based on that whatever that language the developer working on. Maybe there are lot of means people are working on Python, it can be on C++ and other type of coding things. So, that coding part is based on that what sort of problem and what is the environment you are working on, but primarily philosophy there are m number of mapper and a set of reducer, you have intermediate results into the thing, right. So, as we discussed earlier that map phase, each mapper reads one mth of the input from the global file system, right, using locations given by the master. So, master controller, the controller of the master node says that these are the chunks you need to read, right. So, map function consists of a transformation from one key value pair to another key value pair, like here I have a k1 v1 map to k2 v2, right. Each mapper writes computational results of one file per reducer. So, it's prepare typically if there are R reducers. So, it prepares the result for one file per reducer. If there is one reducer, so one file that it creates a file for reducer. Files are stored in a key and stored in a local by a key, sorted by a key and stored in a local file system, right. So, that is a local file system where the output of the mapper are stored. The master keeps track of the location of this file. The master has the tracking of the things. On the reducer phase or the reduce phase, the master informs the reducer where the partial computation, because the mapper has done a partial computation of the whole process, have been stored on the local file system for respective mappers. So, for if there are M mappers for the respective mappers where the files are stored for that particular reducer. Reducer make remote procedure call, request the mapper to fetch the files. Each reducer groups the results of the map step using the same key and performs a function, some function f and list of values corresponding to these values. That means, if I have as k2 v2, then I map it to some k2 and function of that v2. So, the function may be as simple as averaging. So, maybe frequency or the count or some complex function of doing some more operations, right. So, results are written back to the Google file system. So, results are written back to the Google file system. So, the Google file system takes care of that. So, map reduce example. So, there are 3 mappers, 2 reducers. Map function is in this case as we as if you remember or if you look at the previous our previous lecture and discussion. So, that was there is a huge volume of word and what we want to do a word count, right. So, the every mapper has a chunk of the data things, like this mapper has D1, D2, D3 and this is D4, D7, D8 etc. So, every mapper does a partial count of the word, like and for W1, W2, W3 and so forth, and there are 2 reducers. So, it creates file for both the reducer and so the reducer 1 is responsible for W1 and W2, where the reducer 2 is for W3 and W4 and we do a word count on the thing, right. So, there is a mapping function where this is done and there is a reducing function where it is basically the function is for summation of this count for every word Wi. So, that is dividing this word count problem into a map reduce problem. And last talk or last lecture we have shown that this can give parallel efficiency in the system, right. So, we now look at a couple of problems. So, this is not exactly map reduce problem, just to go for Hadoop file system or GFS Google file system. So, if the block size is 64 MB, if you remember, these file systems are larger chunk block size than our natural file system. And another thing was that there is a 3 replica of the of every instance of the data. So, there is a 3 replica where which allows you to have a fault tolerant mode. So, based on that there are read write operations are done. So, in this particular thing, if we say if there are if the HDFS block size is 64 MB, then we want to find out if there are 3 files of 64 K, 65 MB, KB, MB and 127 MB. So, how many blocks will be created by the HDFS framework, right. So, for the 64 KB, how many block? 1 will be created, right, and 65 MB we have 2 because 60 up to 64 MB 1 and 127 MB also 2. So, total 5, but in reality as there are replicas like we have replicas. So, that is typically 3 replica. So, effective block size will be 5 into 3 equal to these blocks, right. So, very straightforward, nothing complex, no complexity in it, right. So, if I have different type of things, so we can calculate this straightforward, right. So, again nothing to do with immediately nothing to do with MapReduce, but nevertheless it is the data is stored in either HDFS or if it is a open source or in GFS if it is Google file system, and it need to be this data size or the storage need to be budgeted when you are working with large data set, that how much storage you require, how much storage you require to work on this type of data sets, right. Now, let us see one problem on very straightforward problem on MapReduce framework. So, whether we can have this MapReduce framework, though again we may not very much appreciate directly because of this simplicity of the problem, but to understand the MapReduce framework it may be good. So, want to write the pseudo codes in or codes in any language that where there are what we want to do, calculate the average of a set of integers in MapReduce. So, a set of integers being pumped into the system, it may be a direct input from the keyboard or something, and so we want to find out the average of the set of integer. In other sense, in this typical case I have set of integer a as 10, 20, 30, 40, 50, right. So, set of integers are there. So, want to make a average. So, in other sense we want to basically sum it up and divide by the cardinality. So, totally divide by 5. So, in this case what we do with the master node, say we consider there are 3 mapper, right. So, there are mapper nodes we consider as 3 numbers and reducer say 1 number, right. So, the what the do in the master node, what it does for this mapper, it divides into say M1, M2, M3, right, 3 mapper node. So, a portion of this data, right, say it gives 10, 20 to the first one, 30, 40 and 50. So, each mapper does a partial counting of the things, right. It does a averaging of these 2 things, right. So, it is something which comes up as I can say average and count. So, first one is 15 2, then this is 35, coordinate is 2 and this is 51. In other sense, it in the temporary local file system is to store 15 2, 35 2, what basically the output of the mapper, right, it does by the combiner. So, this is the map functions wants to achieve, right. On the reduce, reduce is primarily is this one reducer, it takes all the things and it does a averaging of the things or more this averaging of the whole thing. So, in other sense what it does, say 15 start 2, here 35 start 2 and 50 star 1. In other sense is sigma sum is 150, sigma count is 5. So, it says 150 by 5 or 30, or it is basically 15 start 2 plus 35 start 2 Okay. So, that exactly does. So, that as the problem is pretty straightforward or simple, you may not find that what is the big deal here. May not, if the number of things is pretty high coming as a stream, and then I can basically do parallel things, right. These are parallelly processed, and this is reduced by the one particular reducer, right. So, if we write the code for it, so you can use any language to do that. Here, we are using say Python or Python type language. It is the language is does not matter, the representation you can do in any pseudo code and type of things. So, we have that mapper function or say mapper.py. So, it is something Python type. So, we are not much giving importance to the syntax, rather we are more giving importance to the concept. So, def map, so L is the list. So, what we do, we initialize a sum equal to 0, right, for I in range 0 to length of L. Okay. Sum equal to sum plus. So, every mapper does this, right. Every mapper what it does, it takes that chunk of data which is being allocated to it for by the master node, and then for the in our cases how many data is there mapper 1 has 2 data, mapper 2 has 2 data, mapper 3 M3 has 1 data. So, it is 2 to each. So, for every mapper we run this. So, we the average sum by length of L, in this case 2, it should be like this, sum by length of 2. Okay. Or in other more strictly speaking, we should have to have a floating point difference, floating point divide, because this is a otherwise there may be integer division. So, we can ideally give sum star 1.0 divided by length of L. So, length of L in this case 2, right, and then we output this, let us use print function, output this to the local file system, right. So, there can be this command wise, it may be different if you are using different programming paradigm length. So, the mapper basically emit these data. So, it is stored in the local file system. So, what we are doing? We are for every mapper, we are reading a list of data which is being assigned by its master node, making that sum, initializing the sum to value. Then we are what we are doing for I for in the loop. So, calculating the sum, making a average out of it, rather this is nothing but to make it float division, and then it is emitting or dumping that value into the local file systems, which the reducer will read it, right. So, this is the mapper portion of the thing. So, if we look at the reducer portion, so what we have, def reduce. So, what it reads? So, whatever the mapper has dumped into the thing. So, if you look at, it is giving this average value and the length of the thing, right. Here also we read that particular thing, sum equal to So, here for I in range of 0 length of L, right. So, it is what it is doing, if we look at our previous thing. So, what it is doing, it is basically trying to calculate this sort of values. Right. So, count also equal to count plus length of I. So, finally, what we get average again sum, to make it float, just multiply this, or you can basically typecast also count, right, and then print average. So, what it is reducer is doing, taking this local file system, as there are only one reducer. So, it takes all the values, and for all the data it goes on summing up the output from the each mapper. In this case there are 3. So, it is coming to be 15 into 2 plus 35 into 2 plus 50 into 1 divided by count, which is here 2 plus 2 plus 1 is 5. So, and it calculates the average value, and then it again writes the average value to the Google file system or Hadoop file system based on the whatever the requirement is this, right. So, here this is again, though this may be a straightforward simple thing, but we see that I can divide a problem as there are inherent parallelism, like there are I could have, like in order to do a averaging, I have taken a chunk of data, and that we try to solve it using a MapReduce framework. So, it is if there is a huge volume of data, then the mapper that the master node divides accordingly and do the partial computation, and the reducer read it from and do the final computation. Okay. So, this is again a simple example of a MapReduce framework. So, next we see another problem, right. So, what it says, we want to compute the total and average salary of organization XYZ, some organization grouped by the gender, right, using MapReduce. So, input is name, gender, and the salary of the thing, right. In this case, say name is John, gender is M or male, and salary is something 10,000 unit, maybe $10,000 or something. And the next one is Martha, gender is F, and the salary is something 15,000, right. So, what we want to do? We want to find out that male wise, like gender wise, in this case male and female, that what is the your total and average salary. Anyway, that total divided by the cardinality will be the average salary of the things. So, the output will be like in that form. So, what we try to look at, whether we can employ MapReduce problem to look into this particular problem. Okay. So, let us look at it. So, what we are having? We are having this tuple like this, name, gender and salary, right. So, this is the tuple. So, if I so what we want to do in the map phase. So, want to, if the input data, whatever the input data set is there are different set of input data set. So, what we want to do? We want to extract only, because we are not bothered about the gender, bothered about the name of the person, or that is not required in the so in the salary. So, we want to calculate from there these two things, say aim, the salary, so respective, and right. So, want to do type of this type of things, or I can have a key value pair, right. Key is this male or female, and value is the salary of the things, or we can say that we have two sort of dictionary structure, which is having a key value pair, and then having, say I say this is DICT 1, DICT 2, and these two type of key value pair, and for every one I can have DICT 1, then maybe total and average, for other one also DICT 2 ID may be. So, ID in this case is this particular male or female, and then having total or average salary, right. So, compute total average for the two separate in say we consider that as a dictionary structure, and the reducer basically does this thing, right. So, want to see that how to realize this. So, what let us look at the problem. So, I have a set of name, gender and salary, want to extract that gender and the salary from every tuple. So, if I have multiple mapper, so I extract those things and dump as a particular two type of dictionary type. One is that two type of thing, one is that what we have this with aim and f, and at the reducer part we calculate the total and average salary of the things, or any of the things. So, again we look at as a mapath.py or mapath dot some Python type code. So, again I am just want to again repeat it, that you can do with any coding language which is suitable for this, and whatever we are doing may not be, there may be some syntactical problem with the actual Python thing, but it does not matter. The conceptually you want to show that things works, and then actual syntactical syntax need to be followed if you really want to implement this, right. So, for this is the thing, for a line in sys dot std in, what we are doing, so what we are considering that it is separated by a comma. So, we are split is, sorry, it should be comma, right. So, I now separate name equal to line 0, salary represents SAL is line 2, right. While generating the or emitting the mapper phase the data into the local file system. So, we give print comma percentage %d then so what we do, gender and salary. In other sense, this syntax you need to check up. In other sense, what we do, we dump basically gender in the salary into the thing, or M and the salary portion. Like as you see, we want to generate this M and the salary portion, right. And another thing is that either M or F and the salary portion, right. So, in the reducer phase, in the reducer phase, what do we do, that import so define that or call this DITORG, that is dictionary class, for line in sys in what we do, so what it is reading? It is reading basically that the gender or that key value pair with the gender and the value of the things, or in other sense the gender and the salary values. So, we do not have that name into the things, because the this particular query does not require the name of the thing, right. Line of 1. So, if this if so if it is already existing, that means once you have read, then DCTORG So, what is our objective? To basically sum up the salaries by go on adding on the salary values for the same gender type. So, already if it is already there, that means, so what that now my existing the reducer dictionary containing a key value pair. So, the if the key is already that gender is there, or male and female, male or female, then I go on adding those things whenever I get. If it is not there, if it is else, that means this is basically the initialization thing, this CTORG so initialize with a blank thing. So, first time when it is coming, so, when first time it is coming, that means there is a blank thing. So, if it is blank, then it basically initialize, then append the salary, that means it is initialized with the salary of the thing. DICT org dot keys salary average equal to sum of DICT org gender divided by length of DICT-ORG gender. So, it is summing up divided by things, straightforward, right, and total salary equal to only sum of DICT-ORG gender, right, and then we basically write back the thing from to the Google or GFS or the HDFS file system. So, if we want to separate it by a comma or tab, as the case may be, again maybe D if it is a integer, or based on that if it is a float and all those things. So, we have this as gender dot cell and cell AVG, right. So, so that is the what we do at the final reducer phase. So, if we try to just quickly have a look. So, what we are doing in the mapping function, we have three thing like name, gender and salary. Our objective is to the mapping functions to see this all the mapper will find out this individually, this whether it is a which gender M, and keep this salaries along with that M or F and salary, and the reducer will basically, so that it exactly judge gender and salary, and the reducer will basically extract that intermediate result and calculate the average and the total, right. So, here that operation is there, right. So, this is a typical Python type. I am not strictly telling Python because there may be some syntactical issue, but you can implement in anything, right. The idea is that I divide the problem into smaller parallel things by the mapper, and then in the second phase the reducer put it to another key value pair. So, key value from the input set to a set of key value pair, reducer takes that key value pair and put a function, in this case average or total of the things, to another set of key value pair, and finally it goes to the HDFA or GFS file system. Okay. So, what we try to look at in today's thing, that this map reduce functions, say simple problems, how we can put it into map and reduce things, that this number of mappers available is basically availability of the resource, and how the master nodes divide it, and the number of reducers also based on that what type of functional things you want to do. And so, the master node is there, which divides into m number of mapper and n number of reducer. The problem is the functionality of the problem is divided into in such a way, so that it can be executed into phases, and we can have a parallel implementation of this sort of paradigm. Okay. Thank you.